So, logarithms. My screen okay? Can you see the screen okay, Ava?
Yeah.
All right, good. All right, medical research indicates the risk of having car accident increases exponentially at an alcohol level. Here's the equation where X is the concentration. All right, so R of X equals 6 times E to the 12.77X. Okay, what blood alcohol concentration corresponds to 100% risk? So the risk is modeled by where X is the blood and R of X given as a percentage of the risk. So we're gonna R of X is given as a percentage. So 100, we want R of X to be 100. You understand that?
Yeah.
So we plug in 100. Whoops. The X is up with the exponent up there. And so to solve this, remember what we talked about the other day, how to solve this? First, I have to divide both sides by 6, right?
Yeah.
Then take the natural log of both sides. And that allows this to come down to the front, right? So 12.77x equals the natural log of 100 over 6. And now just divide both sides by 12.77. And now is when I punch it into my calculator after I'm done figuring out what it should look like. So the natural log of 100 divided by 6, and then I'm dividing that whole thing by 12.77. So X equals 0.22 approximately. And to check it, store that for your X. I hit the store button right above the question mark on my calculator. And now type in the original 6 times E to the 12.77x, and you should get 100. What you do, 100%.
Okay. So
Questions
you just
about that?
So you just plug. So you just plug the 0.22 back into the original equation.
Yeah.
And then
what I was doing is I was using my graphing calculator with this store button right here. STO button, and that just plugs it. That allows me then when I type this in, that allows that to it basically plugs it in for the X. It plugs that exact value, this exact value that I got in my calculator, not just 0.22 in for X. Okay. Solve the equation with a calculator. All right, so the first thing we're going to do is add 3 to both sides. So we get negative 20, negative 6e to the 8x plus 8. Now I'm going to divide both sides by negative 6. So this just equals, I'll reduce that, 10/3. E to the 8x plus 8 equals 10/3. Right? Now, how do I get that variable out of that exponent? What do I do?
Natural log.
That's right. Take the natural log of both sides. That allows that to come down. 8x plus 8. The natural log of e is just 1, because that is what the natural log means, log base. So the log base e of e is just 1, right? So that just cancels.
Yeah.
Equals the natural log of 10/3. And now add subtract 8 from both sides and divide both sides by 8. And that should give you your answer. So carefully type in your calculator, 10/3. Don't forget to close off the parentheses, minus 8. Now I'm just going to hit enter. So that's my numerator divided by 8. And there's your answer. x equals negative 0.8495. And again, to make sure it's right, store it for x, and then just type in your equation, the left side of your equation again, typing in the x, and it's going to plug in. It's going to plug that into the x, and it should give you a negative 23, which it does. Good?
Okay. Yeah.
17, it says, oh, sorry. Am I going too fast?
No, yeah. No, you're good.
Okay, page number 17, as a town gets smaller, the population decreases by 6%. So that means your formula is going to be, you're going to have that 1 minus 0.06 in your formula, right? So
yeah.
your formula you're looking for is you take your 160 and you're multiplying it by that to the t, where t is the number of years you have, and you want it to end up being 100 students. So I'm taking my initial population, I'm decreasing it by 6% every year. That's what this little thing does here. This is like 100% of it minus 6% of it, which, so it's like 94%, right? It's increasing by 94. You could just write 0.94 if you want. Got it? Same deal. And now I'm just solving for t. So divide both sides by 160. Take the log or the natural log. It doesn't really matter which one you do. Take the log of both sides, or like I said, natural log doesn't really matter as long as you're doing the same on both sides. And that brings your t down to the front. So t times log of 94 equals the log of 100 would be what? 5 over 8. 100 over 160, because the zeros cancel. Take another 2 out of each one of those, you get 5 over 8, right? So your t just equals, now I'm just dividing both sides by this mess right here. So divide both sides by the log of 0.94. And just be careful when you plug that in to make sure you're using parentheses carefully. 5/8 divided by the log of 0.94. And again, always just check your answer by hitting that store button. Store it for x, and then type in your equation, 160 times 0.94 raised to the x, and it should give you 100.
Okay.
So you know you did. Good?
Yeah.
All right. I know I'm going fast, but it's all right. It's being recorded, so you can watch it again later. All right. So this one is one where you don't even need a calculator, because you can see that these are both powers of 3. This is 3 to the negative 3, right? And this is 3 to the 4th. Got it? So what do I do with these exponents now?
Distribute.
Yep. So this is 3 to the negative 6 plus 6 equals, negative 6x plus 6 equals 3 to the 4x plus 16. And then this is that poof thing we were talking about, right? You can just say, get rid of both of those. I just know that negative 6x plus 6 has to equal 4x plus 16. I'm going to move the 6's over, or the x's over to the right so that it stays as positive. I'm going to subtract the 16. And so my x just is, 10. My bad. So x equals -1. And again, you can check by plugging it back in, but I don't even need my calculator for that. I'm just going to plug -1 in for x. So that would be -4. So -3 times -4 is +12. So that's the 12th. That's 3 to the 12th power. And if I plug in -1 here, that's going to be 3. 3 times 4 is 12. So 3 to the 12th equals 3 to the 12th. Got it?
Yeah. So I'm just writing this stuff down.
All good. The population of Europe in 1990 was that much. In 2000, it was that much. Write the exponential growth function. Okay, so this is one where this is a little tricky here. So your equation, I think, is this. Tell me if I'm wrong. Is that your equation? Something like that?
Yeah.
Maybe not with the parentheses around the B, but I do that just so you can see that that R is only going over the B, not also the A. So it says, right, the exponential growth function that describes the population T years after 1990. So 1990 is going to be my initial. So this A is going to be 509. That's always your initial. Okay. Now we don't know B yet. Actually, I'm going to write X here, not R. I think your textbook uses X. Okay, we don't know B yet, but we have to try to find B. That's what we're trying to find. And the way we're going to find this is we're going to use this point right here. So what would your X be if your year was 2000? What would your X be?
10.
Good. Yep, exactly. And what does this number right here represent? Not X, but that's your Y.
Okay.
So I'm plugging this in for my Y, and I'm plugging this in for my X, and then I'm going to solve for B. So 729 equals 509 B to the 10. And see, now I can just solve this equation for B by dividing both sides by 509. Now, this is where some people have a hard time understanding this, but in order to get B by itself now, I'm not going to take the log of both sides because I don't have a variable in the exponent. I have a number. The variable's in the base. So instead of doing that, I'm going to take the 1/10 power of both sides because that'll get rid of that 10. Kind of like,
okay. All right.
kind of like taking the square root of both sides, we get rid of the 2 squared because the square root is like a 1/2 power, right? So I'm taking a 1/10 power and that'll give me my B. So let's plug in 729 divided by 509. Whoops. Be careful with that. Let's insert a parentheses there. If you don't have a parentheses, it's not going to do it the right way. Raised to the 1/10 power. And there's my answer, 1.0365, 1.0366 or something. In fact, I'm going to store this in my calculator. I'm going to store it for X. And then, because then the next question says, what will the population be in 2020? So now I'm going to take my equation. So this means T equals 20, right? 2020, T would equal, 30. Right? It's 30 years after 1990. So I'm going to take my equation now, which is Y equals 509 times 1.0366 to the X. And so I'm going to plug in 30 now for X, but I'm going to use my calculator, that whole exact decimal, not just the approximation here. I'm going to use what I stored in there so that make sure that I have the right thing. So I'm going to raise in fact, you can just go ahead and raise that to the 30th power, hit enter, and multiply it by 509. So your population would be, Y would equal 1495. So this is in millions. So that's actually 1,495,364,000. And so I can be really exact with that if I don't round that decimal from earlier.
Okay, so once you get what Y equals, do you just like put it in like what it would be for billion? Do you just like move the comma over? I guess.
Yeah. I did. Oh,
Okay.
sorry, billion, right? So that's only a million. So I should put 3 more. 342. That's the actual population if I was being exact. Now,
Okay.
what they're rounding it. You could also just say 1.495 million if you wanted to. Or you could say 1.5 billion if you wanted to kind of round it. 1.5 billion. You could say that.
Okay.
Probably just, it depends on how they want you to write it, but
Yeah.
this is the most exact answer. Yeah.
Yeah.
This is the exact answer. This is rounded to the nearest, billion and a half or something. And this is like in millions, which is what they wrote originally.
Okay.
They wrote it in millions.
Yeah. Okay.
Okay.
That was just the thing confused me because I found Y and then my teacher said that, well, on the answer key it was like 1.5 billion, and I was just like confused on how you converted like the
Yeah,
uh
you could just keep it like that. She shouldn't mark it off for that or
okay.
for that. Any
All
of
right.
those are fine. But the most practical answer is just to say 1.5 billion, right? That kind of just sounds better and makes a little bit more sense.
Okay.
It's not like the exact answer really matters because this is an estimate anyway. This is a model. This is a growth function. It's kind of a model. If you were going to say this on TV or something, or if you were going to give it like a speech, you wouldn't say 1.495 million or 1,495 million. That doesn't make as much sense as just saying about 1.5 billion. You know what I
Okay.
mean?
Yeah.
So you can see what happened. It like tripled almost in size because it was 500 million. 500 million is 500 million. It was 500 million in 1990, and it's tripled in size 30 years later.
Yeah. All right. Yeah, I should to go over those couple things I was just confused about, but yeah, that's about it.
All right. Well, hopefully you have a test tomorrow.
Yeah.